Yeah, let's pull you out, pull you. We need to know if the audio's working good.
Oh, okay. All right.
How come we have to do these goddamn things
Can you hear me
twice?
now, Frank?
Once a day before,
can you hear me? Is that
and then
better?
the once a day of, and then once a day before. All right. Hello, everyone. Welcome to day 3 here of Hostech Live. We're over here in the products area again. I'm not going to go through the whole spiel because we're trying to blow this out quickly. Let's head this way. So everything's awesome, right, Brian? That's right, Andrew. Okay, cool. Let's head over to this this super dope ass machine right here. This is the VMT 750. This is Haas's first interpretation of a mill turning machine, and this is very much a concept machine at this point. Kind of looking at how, you know, Haas is kind of thinking about how we want to do mill turning, and we've kind of been talking about this. This is kind of more mill than lathe right now.
Yes, it is.
But,
Yeah.
but we've attached this ST15 spindle head here to the table on this essentially VF3Y machine, right?
That's it. It's a VF3 YT.
Right.
And we put the ST15 spindle on it. We just slapped it right on there.
Just essentially, it's not right.
Just
There's
slapped it
a
right
few
on.
other special things you're going to see. We've got a tilting head.
Correct. Yeah. And then lathe work on a mill.
That's right. Yeah, and we're going to get into this more in a minute or two, or 10 minutes maybe.
Yeah.
But you can do a lot of things with a mill turn. Of course, that's why people are interested in them. Why don't we could talk about how we program it or how you program it, but first let's talk about how we control the spindle when you're turning, because that's kind of an interesting thing.
Yeah, the first part of the demonstration is going to be the lathe work. So we can discuss. I'll put it in the right orientation for lathe work, just to show you the travel we've got right now from the tip of this insert to the front of the chuck's roughly about 23 inches, and in the position it's right now, it's probably like 6.5 inches down to the center line. So you could probably put in a part that's maybe 12, 13 inches. But yeah, there is length, but you've got to be wary. When that B-axis does change to 90 degrees, you're going to have a lot less travel on your X-axis.
Right, right. When I first was looking at this machine, I thought we might be looking at
Oh, I see. Yeah, so when I go in and change it, I just come back out.
So he should try to kind of be in the center right here, right?
Okay, all right. Okay, all right. Yeah.
So, yeah, when we were first talking about this machine, I was thinking that maybe we were talking about a work envelope like that big, but really,
no, it's quite substantial.
It's actually quite a substantial work envelope.
Yes, it is. Yeah. So we've got a lot of room to play with, a lot of opportunities to put different kinds of parts on this machine. Yes.
Right, and you're kind of, in some respects, you still have a fair amount of what you would call Z on a lathe.
Yes.
But you've got a lot more X and Y potentially.
Yeah. Oh yeah. It's compared to a Haas lathe, where your Y-axis is only 2 inches either way. You've got 4 inches of travel. This has got way more than we require for a 12 or 13 inch diameter part.
Right, right. So maybe let's just talk to us for a minute about how we have it programmed right now.
Yeah, so the turning tools do come in. By the way, it's a HSK 63A spindle, so that's the holders we've got. They're standard off the shelf.
Right, so these are not custom tools you have in here.
They're not custom tools. This
Typical
holder,
mill turn.
Yeah, this holder's got an actual tool in it, and then we've got tools like this that actually come, and it's just the insert that we replace. It's the holder and the tool itself is stuck together.
Right, right.
So yeah, the tool comes in, it loads in a certain orientation. We've programmed it in M19 to rotate to the lathe position, and there it's going to lock in hydraulically, and then we add the brake.
Essentially a hydraulic brake on the spindle that.
There's a hydraulic lock, yeah, and then the brake is activated after that, so it stays solid, and we can run the lathe part. So, shall we go ahead and?
Yeah, let's do some turning.
All right, okay.
Right off the bat, let's get rolling.
At the end.
Way later, buddy.
After the machine, yeah. Yeah. Sorry. So there it is. It's orientating. It's locking into place. And here it goes. It's going to start cutting like a regular lathe. Facing the part off just to get the part ready. And it's going to start turning any second now. So The speeds and feeds that we are using are just regular lathe speeds and feeds. We haven't
Right, so
slowed
you're
it
gonna slow
down.
the way down. You're at a typical cutting, right?
This is typical cutting. It's running at 1200 RPM. Depth of cut's 100th hour side. Feed rate, it's in inches per minute because it is a mill. It's at 20 inches a minute, which is about 16 thou feed rate. So it's
Your chip load is pretty respectable.
tip load's actually on the high side of what we should be running at for on a lathe. So yeah, we're just going to mill. We're going to turn the profile, and like I said, no issues. Its finish is great, very solid. But you know, they put this machine together in such a short space of time, and it was on the floor a couple of weeks ago. We've got to play with it for about a week.
Yeah, you had it. You might say you had an alarm or two when we were first getting this thing running.
We've had a few little
yeah, you
issues,
definitely
yeah.
worked through. And once again, this is completely a concept machine. This is not from what I hear, Haas is fully intending on putting this style of machine into production. But this is kind of a first step, you know, deciding how things are going to be laid out.
Yeah.
So the final machine may not look exactly like this, but
Correct.
we already have a pretty solid entry right here.
This is the first try, and it's excellent. We've had no look. Well, so far we've had no allowance. Let's wait and see.
That's
so
right.
this is a finisher, just doing the profile, and the next tool is going to be the groove tool. That's going to be our last turning portion, and then
if we do have any issues, then we can chalk it up to being a brand new concept
yeah.
machine.
We're going to blame somebody else.
Get out
always.
of jail free card.
Yeah.
Maybe not.
So the groove tool's going to orientate to the correct position.
Okay, so it switched orientations there.
Correct. Yeah. Every time it gets the tool change and it goes to the lathe position, it has gone to the predetermined R value.
So it's is that kind of equivalent to the position that your tool holder would put your traditional turning tool rigidly in?
It's in the exact position for that,
Right.
yes. So we're just going to put some clearance at the back of this part so we can start and showing you the mill work and the B axis. Basically it's a VF3 YT, but we've added the B axis, so that's what we're going to show them.
Right. This is where the really exciting part maybe comes in.
Yeah.
It's pretty cool to see turning happening though on what's otherwise a milling machine.
Well, yeah. Well, speaking of turning, now we've finished it, we can talk a little bit about why would you not do this on a lathe with live tooling?
Right. Why wouldn't you do this? I mean, you might try the same job on a live tool lathe, but what are the benefits of doing it this way?
Yeah. So on a live tool lathe, you're kind of restricted on your. We talked about.
So when you're backed up, you probably want him to come more square, right? Or does? So when Sal backs up to go away from looking in there, does Bob need to kind of move back, or because we're kind of talking to each other?
We're going to be talking for a second.
Yeah, but I think when you're talking, you need to
Here.
always stay forward.
Stay off
Okay,
that
so
line.
I'm fucking things up. You're doing exactly the right thing.
All right, so stay on this line.
Okay.
Stay on this line. Okay.
All right. So we're pretty much talking to each other. Okay. All right.
So yeah, you're restricted on the y-axis. You've only got 2 inches either way, and you're also restricted on your x-axis how below the part you can get.
Right.
So you end up, your only option is when you're doing the milling, is using the c-axis motion, and it's the least preferred way of milling. You'd much rather do it. You'd much rather do it with X, Y, and Z.
Right.
So you can do it solid. So this machine allows you to do that. That's not the only thing that's a bonus on here. I love it because we don't have a turret. So you don't have to worry about the neighboring tools that might hit the jaws and all of a sudden you hear a helicopter sound. You don't hear that stuff on this because
Right.
there is no neighboring tools.
And you've got all those pockets up there.
Absolutely. So on a regular Haas lathe, it might be 24 stations, it might be 12 stations.
Yeah,
You're
if you're on a
restricted.
24 station turret, you are packing them in there.
You're packing them in there, and you're looking at you're always going to be aware of what tools are next to each other, and it's a pain. This I'm not worried about anything.
A pain you've been dealing with for your whole life.
Oh yeah. So I'm kind of happy about this. I've wanted something like this for a long time. So and then 50 station, you can stock up with tools for a different variation of jobs, not just dedicated to this part number. You could stock that up for 5 or 6 part numbers.
Right, you've probably got, I was just thinking, you probably have 2 to 4 times the number of jobs worth of tools up there that you would if you want to, let's say, a 12 station.
Yeah.
I mean, 12 tools in a lathe is kind of typical, you know, somewhere in that range in terms
Exactly.
of usable stations.
Yeah, on the first demonstration that Corey did about the robots, there were some people on the post mentioning about the pusher on the robot being on the
taking up a
robot
station.
instead of the turret because it takes up a station. And there was a few comments about, yeah, that's a bit of a pain. It is, and this will eliminate that issue.
Yeah, right.
Yeah.
Right. And you're also going to show us some quick change tooling a little bit later,
Yeah.
and that kind of even increases your speed of job changeover.
Yeah.
So, of course, if you've got all those tools up there, those are all tools, once the offsets are set, you don't have to come and set those when you swap them out. So
Correct.
it's a lot less changeover time that way, too.
Changeover time is eliminated of that, basically.
Right.
It's all there. So,
Or much reduced.
shall we watch the B-axis run?
Let's do it. That's
Okay,
what
so-
everyone's going to want to see for sure.
Okay, so now we're going to the mill portion of the, and we're going to index over to the B-axis. So if you can see the B-axis move now, Sal, it's gonna put the end mill in.
Yeah, you're probably, oh, okay. So you're going to want to kind of push in here, Sal, and get
Sal,
closer.
So the B-axis is going to go into position, and then it's going to tilt to 5 degrees. So the cool thing about this is the B-axis gives you a range from 0, which is vertical, to 45 to 90 degrees. It gives you a whole range of options. It adds more. You can put different part numbers in here. You can put intricate and complex parts in here. It really does open up a whole range of different part numbers. So this one's tilted at 5 degrees and it's milling a flat and it's going to add a pocket. And then the next tool's going to come in at 15 degrees and add a keyway. So we're going to watch that go through.
It's a little more obvious when we get to the 15 degrees, but even here, of course, what's X on the mill is
Yes.
moving. Both X and Z are moving so
Yeah.
that you don't gouge into the part.
Correct, yeah, everything's programmed. This one's point to point, but you can do it in G268, which is a tilted plane. But everything's programmed. As it's going across at 5 degrees, it is actually moving in Z to stay on that correct plane.
Right.
Yeah.
So it's very much the way the y-axis works on a regular y-axis lathe.
Yes, yeah.
Right.
Right now it's just milling the pocket. And now
Yeah,
we're going
once
to
we
come
get to
over.
the drilling is where it really starts to look
Yeah.
scary. You're like, whoa.
Yeah. So
How's that drill not breaking?
I've got an optional stop just to make sure. I might have to clear the chips at one point. So
Right, right.
So here comes the 1/4-inch end mill. It's going to do a 15-degree pocket on the taper. So there it goes till it's to
Right.
15
So now
degrees.
we really start seeing some tilt in there.
Yeah. And away it goes. And you can see it more drastically on this one where the Z is adjusting every time
Right,
it goes.
right.
out
You
to
can
stay on the same
definitely
plane.
tell now that you've got Z-axis up and down motion.
Yeah. And you can also do, well, we haven't got the capability right now, but it's TCPC. So you can actually move your B-axis while it's machining. It is going to be available. We just haven't had time to
Not
to
on
put that
this
option on here.
concept machine yet.
Yeah. So I'm just going to stop it right there just
Right.
to clear
So
the chips.
you could do profiling in this manner as well,
Yes,
right?
yeah.
Right.
So the next tool is the drill. So Sal, if you could get in there, when the drill comes in, we're going to do a few holes.
Yeah. Let's get in close on this one too, Sal, because this one's kind of the most dramatic in terms of
Yeah.
Z-axis motion, I think.
So it does tilt to the small 5-degree angle. We're going to punch a couple of
Right, you
holes
can
in there.
just tell that
Just
it's
slightly,
tilted.
but you will see it tilt because we are going to put some features on the front of the part right now as well.
Right,
so,
right.
Sal, it's going to mill here. It's going to clear out the way. It's going to tilt down. It's going to move over to the
Yowzer.
B-axis,
Oh, dear God.
and you're going to punch some holes in
Holy
the face.
crap.
Oh, sorry.
That was crazy.
All right. So you might have to go wide, and it's going to
That'll
clear
be-
back, and it's going to go back home as well.
Holy moly, that thing moves quick. That scared me right there. That was awesome.
The B-axis.
Yeah, he's going to say B-axis is rotating to 90 degrees because
Yeah.
he's doing the full 90-degree move.
Yeah. And we've got a
So now you
final.
do a little bit of chamfering.
Yeah, we're just going to do the profile on the 5-degree, and you'll see it wrap it up, clear, adjust to the 15-degree so it can perform the chamfer on the keyway as well.
Right, right.
So it should be any second now, Sal. It should just clear out the way, just tilt a little bit more, then go back in and perform the next motion. It
And you've
opens up.
chosen those retract points and everything in terms of how far away you want to get to make sure you've got clearance for your tool. So you're not
Absolutely,
crashing
yeah.
during.
Yeah, TCPC, you could do that in one shot with it right there, but we haven't got that activated right now.
Right.
So basically, that's the
Super
mill
slick.
turn.
I love it. So now
And
you were also going to.
the advantage of the B-axis, so a lot of people should have to. How am I going to say this? You can make really complex parts, expensive parts that take a lot of machining on 3 or 4 different machines,
Right.
and move it over here. With the B-axis on top of the lathe and the mill, it just gives you an option to reduce the amount of machines in your shop floor to just maybe this one machine. What else is there?
I mean, that is going to be often, that's probably often the rationale for getting a mill turn style machine.
A lot of times engineers come down to the machine shop at Haas and they've got a part that they think, hey, can you make this? And we come back and say, yeah, it's 2 or 3 operations. Sometimes they even change that component to maybe 3 different parts.
Right, to remove all those ops.
To move all those operations and let assembly deal with it. This machine allows you to do that one component, consolidate that back to one part. I walked to the shop a couple of weeks ago and we saw a lot of opportunities that this machine could provide.
Yeah,
so
that's great. It's good to hear. So were you going to tilt the B-axis just for fun again, just manually?
Yeah, I'll just
we talked about how maybe folks would want to see that, just because it went so quickly there.
Yeah, I'm just going to walk it. We're just going to walk it around just to see. It is a full 90, and you saw it do that when it was doing the drilling.
Right.
So we're just going to move it.
So obviously you certainly got to keep your heads up about where, but
Yes.
I mean, you're not going to have fixturing and stuff on that side, so you're not going to have that kind of an issue.
Yeah, this is a lot of mass coming round here.
Luckily it is moving into a space though that's typically going to be clear though, I think. So
yeah,
that's good.
The other cool thing about this, everybody might be wondering, if you're drilling a tap in or something and you're at this angle, how do I retract out? There's only X, Y, and Z that you can move in. John yesterday talked on the GM2 about the vector jog. So that applies to this machine as well. I'll just do that quickly right now. So if you are stuck, your drill is stuck inside a hole, and you need to retract it at this angle.
Right, so normally you'd be trying to figure out how you're going to do that with X and Z together, or Y, X and Z.
I'd just unclamp the part and take it out with the whole part.
Right.
But with this, you don't need to do that. Handle jog.
And that's that's obviously going to happen at some point.
It's a common thing to happen, yeah.
Right.
So even with your turning tools, you might need to do this. So handle jog, you're going to go V, J. It's going to bring up and highlight everything.
So now you know you're in that mode.
We're in that mode, and I can slowly start jogging out. And as you'll notice that as I do, here we go. As I do that, I should go faster actually. As I do that,
right,
the X is going up. The Z is going up.
Right, and
the X is
back.
moving back as well, so you can safely clear out of the way.
And this is a very good. It shows you too what's happening when you have those two things in simultaneously linked to each other.
Yeah.
Now, so you moved the axis when the door was closed and it moved really fast.
Yes. When it was running.
Can we practice that again?
Oh, okay. Yeah.
Yeah, we're going to say he's going to talk about how he's going to rotate B axis to 90 degrees at the end. Can I just do one for me for the edit?
Yep. You want to run it the drill?
Yeah, let's just run it.
That's fine.
Run it without
absolutely
without cutting.
No, that's fine.
Or just the drill, yeah.
It'll do it. Just
just from the option stop.
You want the drill, right?
Yeah. We're just going to run that last part.
Okay.
Of it. Okay.
All right, who wants to get in? Do you want to get in?
Yeah, that's good. All right, so now you're
at 5 degrees.
Okay, so we're at 5 degrees, and then we're going to do 90.
As it's coming down in Z, the X is moving along with it to keep it in the right position. So this is a good idea. It's how accurate it is because it's drilling the same holes before.
You'd break that drill in a moment if it wasn't right.
So just a little squeak.
All right, so here we go.
Yeah.
Big, quick, yeah. That's
and then
scary.
you're into the Z mode. So now you're drilling the face. You could actually center drill it. Whatever you want to do in this feature.
Right.
Yeah.
And you can still do end milling. You can end mill on that face as well, right? So you'd be doing Z and Y.
So many options that you have got now, especially with the B axis moving while it's cutting. There's so much intricate stuff that you can do on this thing.
And so is it a functional C-axis on it as well?
Doesn't work. If you go C, if I move C180, it's going to start machining over here or over there.
Oh, okay, right.
It's going to go walkabout, but we haven't.
The plan is to, right.
The plan is
I'm not, I'm just, that's
don't
just
say
for
anything.
now.
Yeah, don't say
What about Z-axis, bruh?
Yeah. So, what? So yeah.
So that's great. So we got our way through the demo. Not one thing crashed. I love it. So we were going to talk a little bit about the tooling that we have on here. Of course, got a couple plugs for some of the Haas tools, but we're also going to look at some of the tooling we have mounted on the chuck here.
Yeah.
The chuck itself.
The chuck itself. Yeah. So we did use on the turning a couple of tools were our from HaasTooling.com, and so three.
So Frank, you're pulling those slides up for the tools.
For the
All
end,
right.
for the end. So the. Yeah. So we've got two end mills and a tap that are. The two end mills, a drill and a tap that are on the.
Cool. So Frank's gonna put up the slides for these.
Okay, yeah, that's
Right.
it. So you should have two end mills, a drill and a tap.
Yeah. So Frank's gonna. Yep.
There's some here.
Oh, let's put them on that shelf.
Oh, okay. All right. Yeah.
All right. So these are couple of the tools that we were using in the demo.
Yeah.
I'll let you talk about this, Zop. But I mean, it's a couple of end mills, a drill, a tap, and a.
Yeah, we've got some turning tools as well. The rougher and the finisher that we use were from HaasTooling.com.
Yeah.
Yeah.
Look at this, it's lathe insert.
It's
oh
a
my
lathe.
God, mind blown.
This is the sales part of it, isn't it, Andy? You should be doing this.
Fucking jack off.
Yeah, these inserts are on our web. Well, will be available on the lathe. The lathe inserts will be available. The mill inserts are already on the website, so you can search for them right now. Okay, like that. All right.
All right, there we go. Oh, you're giving me a boner, man.
All right. I didn't use the tap, but there you go. I'm going to put it in tomorrow.
So no, don't worry about it.
So
let's just do the end mills.
Yeah.
Fuck the tap.
There was one thing we forgot to mention.
No tap. Don't need to add anything, buddy. It made it through it. Let's not worry about it. Let's not fuck with it.
I agree. All right, no tapping. All right.
Ah. Yeah, because I mean, we saw that. We saw both of these tools get used.
Yeah. Well, also.
And then so we'll say.
Oh.
We'll just mention. We'll say, hey Frank, you got the slides for these tools, right?
So you're gonna talk about the mill tools first.
Yeah.
Transition to the lathe tools.
Yeah.
So,
I mean, there's not that much to say. It's like.
So the.
Maybe like 5 seconds and 5 seconds.
Okay.
Okay, all right, that's fine.
So
we
the
give you more than that.
All right. So the drills, end mills, and taps that we did use. Oh, sorry. The drills and end mills that we used were from HaasTooling.com.
Right.
The lathe inserts, they are currently not on HaasTooling.com.
But they're definitely coming soon.
They are available and coming soon. And on top of
Because
that,
this guy right here has been testing the crap out of these.
Yeah,
I should say,
can we say that?
testing these quite proficiently and something or other.
yeah. And on top of that, we've also, if you can get on here, we've also got the Haas collet chuck that will be available
Can you jog
soon.
that over? Can we see that if we?
Oh yeah, yeah.
Yeah, because we're gonna do a super quick little demonstration here on
Yeah, so it needs
popping
to be
this
here.
out of here, right?
Yeah, we were talking about changing over. For
That's
the
right.
setup
We got
tools.
all the tools up there.
Correct.
This is kind of the second. This is a cool second half potentially to that.
Yeah, this is just to show off the Haas collet that we've got right now.
Now this is also coming soon, I think.
This is coming soon. This is
Right.
not available yet. So what I'm going to do is I'm going to change over right now. I'll just discuss what I'm doing as I'm doing it. So I'm going to
do it.
unclamp the finished part that we've done. So say we've completed this job already. Move this out of the way. I'm going to be right here with. We're going to use this cool looking gun. We're going to remove the collet.
That was quick right there.
Place that collet down here. I'm just going to use a wrap just to make sure there's no debris before I put the next collet in for the next part. And the same thing again. Grab the collet.
Oh yeah. Does that index or does it kind of go in anywhere you
There's a
want?
slot right here that I'm going to find. So somebody really needs to be over here, don't they?
Yeah. Okay, cool. Can the inside camera see it?
Yeah.
Awesome, perfect.
Okay, so we're going to lock that into place.
All right.
And we're going to clamp this 1-inch bar. And we're ready to set up the next job. We've already set it up.
That's awesome. And
That's it.
your work offset for that material is set on the face of that truck, right?
Correct, yes.
So that hasn't even changed.
Correct.
As long as your program references that same one.
You just got to stick this out the right amount. You could either use a pull part to stop or you could measure it. But you're
Right.
ready for the next job.
So work
Change-
offset unchanged, potentially tool offsets unchanged because you've got so many tools here.
Everything's done.
Switch over in what, a couple of minutes?
Couple of minutes, yes.
Yeah, that's great. Well, thank you. I think that's about it, right?
Yeah, I think we just want to know from the viewer, because this is a concept machine, we just need to
That's
know from
right.
the viewers what they think. Would they buy it?
Exactly. What do you think of this approach to mill turning?
Yeah. Is there, give us some ideas about what he's like on it, or an idea of what kind of parts you think would be good for this machine?
Good time to say, type it in the chat, leave us some comments.
Yeah, that's
Yeah.
it.
Post down
Yeah.
below the video.
Yeah, what he just
Yeah.
said.
Yeah. So if you've got ideas, if you've got kind of ideas about how you might use this machine or what you'd like to see on it, option-wise or feature-wise, definitely add it to the comment on the video here, or even email us
Yeah, either way.
at whatever. I don't even know what email we're using. Forget the email.
Yeah.
Yeah. Leave the comment in the chat. We're going to be reading them, taking notes. So thank you again, Bob,
Thank you.
for walking us through this mill turn machine. And now we're going to head over to the UMC 500 APL machine, and we're going to let Brian and Corey take over and look at how we add the APL to the UMC 500. I don't know why I'm moving over here. You should probably go over here. Yeah, so you're probably there, right?
Yeah. So Brian's gonna be doing this one tomorrow, or?
Yeah, Brian's gonna be doing this one. We're gonna
Okay.
he'll be waiting. He'll take over with you, but
Okay.
I'll be in place of Brian for
Okay.
now.
All right, no worries.
Sorry?
We'll have someone to move all these cables.
Yeah, one of us. Yeah, someone will.
Yeah.
Person, I think.
Yeah.
Was I getting in your way or what? No. Was I getting in your way or what?
So I think if you're kind of always just in the middle, I guess that pretty much works, right?
Right here. Always outside the light. It'll give me.
When I was doing the culling, which you see.
Really?
Yeah.
Don't worry about me. Oh, yeah, cool,
Yeah.
cool.
So if it gets extra difficult putting in, we'll see every wince. Alrighty, so we've looked at APLs attached to lathes and VMCs.
Yep.
So kind of the same idea here for sure, right?
Yeah, it's basically the same thing. It's basically the same as the mill robot that we've already, or the mill APL we've already seen. It just is hooked up to a UMC.
Right.
Wow.
So in terms of programming it, I'm assuming it's pretty. I've looked at both the other machines, but I have not seen this yet. But I'm assuming it's similar in terms of this. I'm sure
Yeah.
it's nearly exactly the same in terms of the sequence of the templates, right?
Yeah, so it's actually exactly the same as the mill APL. The only difference again would be the GIFs that are displayed here. Show everything going into
So
a
the
UMC.
GIFs are specific to the UMC.
Yes.
Okay, wow, that's cool.
Yeah, so you get a nice little picture there of your
Oh, yeah, look
UMC
at that,
with the
wow.
APL, and show one going in here, going and placing it. It'll place it on the UMC table here too, since it will be recording on the UMC like the C and B axis as well for the load axes.
And once again, I'm assuming all the axes are the same, right?
Yep.
AW, AV, and AU are all moving in the same.
Yeah.
The table's still AV and.
Yep.
Right.
It's W, U, and V, just like X, Y, and Z.
Right.
And that's the same across all of the APLs.
So again, if you've done one, the other ones are going to be pretty easy.
This will be very familiar.
Right.
Yeah.
Right.
But for people that haven't done it or didn't see the previous ones, I guess
right.
we'll go
exactly.
through.
Let's walk through it.
We'll go through it all step by step. Do we want to do the whole thing today, or
We
are
don't
we
need
just
the
doing
whole
a
thing,
quick?
yeah.
Okay, we can just quick version. Okay, so it'll be like.
So aside from, you'll walk through the basic programming sequence, right?
Yeah, just basically how we did the robot, because it's very similar. You don't show it probably.
So actually we'll do a few of the moves?
Yeah, like I'll do a new program, you know, and show the initial pickup location, come down, grab a part, record the ready location,
Okay.
and then be like, okay, you just set it all like this, you know, and set it in there, reset, and then we'll show the demo program, basically.
Right, so you will run load and unload one or something?
Ours is actually doing machining parts in there too. So
Okay.
they're like short times, like 2-3 minutes, but
Okay.
maybe we only want to run 2 of those or
Right,
something.
yeah.
So
And so is there anything after that that's different or that's in addition to,
no, the real
like
one.
anything else you want to practice right now?
Not really. I think I'm pretty good on it. It's really similar, honestly. It really is the same thing. It really is like the same thing. So
Right. I'm assuming maybe Brian will even kind of mention that. You know, maybe you've already seen this, and this is going to be similar to what we've done before. But if you haven't tuned in to see these other machines,
yeah, we'll go through everything.
yeah,
I
we're going
think,
to walk
so.
through it all just so you get a chance to see it.
Yeah.
Cool. Well, I think that's it.
Yeah. Okay.
Okay, so Brian has an outline from you for
Yeah.
this thing? Okay.
Yep.
As long as he's got an outline, I've got an outline for this. Should be good that way. All right, so that's the morning. Cool.
Cool.
Thank you, sir.
Yeah. Thank you.
Was Corey's audio okay?
Beautiful.
All right.
Beautiful.
No, it couldn't have been any better. I was
Wow.
teary-eyed.
What?
Oh,
the-
wow.
Okay. All right. So now it's just Marcus and I after lunch.
After the break, yeah.
Is Marcus still out here, or did he run back inside?
He might have ran back inside.
Yeah.
From here to here, I'm basically doing a 180 to Brian and Corey, right?
Yeah. I'm going to say, so now we're going to throw it over to Brian and Corey. They're on the UMC 500 with the APL. Yep, and I'm assuming it's you to start. Yeah, and then Tyler will follow. Yep, and I'll probably I think we'll just go this way. Cool. So Bob, when we're closing out, we'll be over here. When we're done, we'll sorry. I'll say something like, "Thanks a lot, Bob." Now we're gonna throw it over to Brian and Corey. They're gonna be standing right there. Sal, we're gonna actually go this way. So Sal's gonna rotate first, gonna get on them, and then as soon as we'll wait for both of them to move, and then we'll go out this way, out the back.
Oh, Brian's going to be over there.
Yeah, Brian, they'll both be over there.
I see, actually, they'll go that way. Okay. All right,
Yep.
no problem.
Cool. Okay.
Should I just leave this one on for Marcus, or?
Yeah, exactly.
Okay.
Let me go grab him and see if he's in there.